So once we've written our assembly code, so you can use any kind of text editor to write the assembly code, we'll run it in the CPU emulator. So this is a software tool provided as part of Nanta Tetris, and this emulates the behaviour of the complete hack computer. But once you've actually finished building the hack computer, use it by writing the HDL files for all the different parts. You can actually run the machine code in the hardware simulator, but the actual CPU emulator just emulates the kind of completed computer. So with the emulator tool, we can either load assembly code directly, so this is the raw assembly code of the .asm files, and then it automatically assembles these into the binary .hack file, so the actual machine code. So these ones and zeros are the things that's loaded into the ROM, the memory, the instructions. But we could also, so with the emulator, we could either load the assembly code directly, or we could write the assembly code in a text editor, use the supplied assembler tool. So this is a separate tool that will then convert the assembler code into the hack file, and we could load that hack file into the CPU emulator. So there's different ways of doing it, but generally the easiest way is just with the CPU emulator load the assembler code directly. So this is showing this window shows the CPU emulator. So it's simply load our file. So this is just a very simple example how to add two numbers together. So we can also look through this code, so we can see. So this has just got 6 instructions. So they live in slots 0 to 5 in the read-only memory. So you can see this this window here, where we'll see that's our instructions. So you can see first. So when we execute this, which we do by pressing this run button. So when you press that, you'll see this yellow line will kind of step down, so we'll see it stepping through the instructions. And as you do that, you'll see the program counter will increment. So this window here shows us a program counter. We can also see the values of A, and then over on this part we can see the contents of D, and the inputs going into ALU, and the output, and so on. And then finally, this window here shows the contents of RAM. So the left one is RAM. Sorry, the left one is the ROMs and instructions, and the right one is the actual RAM. So we look in this simple example, we can see the first instruction is just at 2, so that will load the value 2 into the A register. So at that point you would see a 2 appear here, and then in the next instruction we do D equals A. So then when you saw that 2 then will be copied up into the D register here, and then the next instruction at 3 again we'd see the 3 go into the A register. And then now we're going to do D equals D plus A. So we've already got 2 in here. So once that instruction has been executed, we get 5, which is what you can see now in this window. And then after that, the next instruction at 0. So that's going to set the contents of the A register 0, which we can see here. And then the next instruction, M equals D, will then copy this value into the RAM slot 0. So that's why 5 appears here. So with the CPU emulator, you can write your code and you can go through it line by line, watching how the program counter increments, or you might see it do a jump, and you can watch how A, D and the memory changes, and then you also see what's going on with the LU down here.